Hello and welcome students. We will take one more problem in differentiating logarithmic function. So the next problem which I shall take for you is 7th. In this we have sin x the whole raised to x. We have sin x the whole raised to x. So I will begin with writing let y equals to sin of x the whole raised to x. Now in this what I want to tell you is this function is definitely not having too many multiplications. Like you do not have here too many multiplications, you do not have division, you do not have exponential, you do not have power. Like earlier I said that if you have too many multiplications of expression, like in this you have, if you have numerator and denominator, like in this, if you have the powers like here, so for differentiating we take help of logarithm, we take log on both sides. Why? Because log will change the product to sum, it will change the difference to, it will change the quotient to difference or division to difference, it will change the power to coefficient. So all those things are not working here. In this question number 7, it's a different question. What I want to tell you here is, look at this function very carefully. What kind of function is this? If I go for, say I go for direct differentiation, if I start differentiating it as it is, if I write here differentiating with respect to x, if I write differentiating with respect to x, then I would get d by dx of y equals to d by dx of sine of x the whole raised to x. As usual, I will ask you what kind of function is this? You know, if you do not know the name of the function, you would not be able to apply the proper result. So recognize the function. So when you go for recognizing, you will understand that this function is variable. Look at this, sine of x, it's in x, so this function is variable raised to, look at this is also variable, it is variable raised to variable. We have not had any result which will differentiate variable raised to variable. What I am trying to tell you is, we have had derivative of, we have had derivative of d by dx of x raised to n, which was variable raised to constant. I know derivative of variable raised to constant, x raised to n. What it was? It was nx raised to n minus 1. Then we had derivative of d by dx of a raised to x, which is constant raised to variable. I know derivative of constant raised to variable. But I do not have a result, ready-made result for d by dx of variable raised to variable. So this is new for us. Variable raised to variable is new for us. We do not have a ready-made result for this. So what do I do? I hope you all are understanding what I'm trying to say. I'm just saying that I do not have a result as of now for differentiating variable raised to variable. So what I do, student, is as follows. Remember, it is now a rule. When I notice that I have a variable raised to variable function, then since there are no results available for it, I am left out with one single option, and that is taking log on both sides. I am taking log on both sides. Now, what way does this help me? It will get me log of y equals to log of sine of x raised to x. This will get me sine x raised to x. So what will happen, students? So right hand side, it will become x log of sine x. It will become x sine of log x. I'm sorry. What it will become? It will become x multiplied to log of sine x. Why does this become? Because you know log of m raised to n is n log m, and this here you have log y. What happened? Try to understand. What happened was, when you took log on both sides, the very next step the power become coefficient, and now you have no more variable raised to variable. See this, there is no variable raised to variable anymore. Now what it has become, my dear students? It has become u into v. This is u, and here you have got v. It is time now we differentiated this. So here I will write here differentiating both sides with respect to x. So this will get me d by dx of log y, and here you have d by dx of x into log of sine x. This is x into log of sine x. D by dx of x multiplied to log of sine x. So as you know, students, this x is u, it is function of x, and this x, this sine of log of sine x is v. So I will go for product rule. So the right hand side I will get x into d by dx of log sine x plus log of sine x into d by dx of x. This will get me here x, derivative of log sine x. This is log f of x. Okay, so what it will be, 1 upon sine x into derivative of sine x, which is cos x, plus log of sine x, d by dx of x is 1 into 1. And the left hand side, here you will get 1 upon y d by dx of y. Here also 1 upon y d by dx of y. So d by dx of y. So I get here finally, therefore dy by dx will be y. This y on the left hand side, which is in the denominator, it will go to the numerator on RHS. You got here x cot x, x cos x upon sin x is cot x, plus log of sin x, log of sin x. The next step what I do is I substitute what y was. So this is dy by dx equals to sine of x the whole raised to x, which was y. Then inside the bracket x cot x plus log of sin x. This is final answer. You can replay the video and learn this once again. This is final answer. Okay, thank you. Now some problem for you. I solved this sin x the whole raised to x. You will go for this problem number 6 is for you to practice. What you will do, students, here, what will you be doing here? See, you will begin with writing y equals to x raised to tan inverse x. This is once again variable raised to variable. Remember, students, the moment you see variable raised to variable, you cannot differentiate it directly. Why? Because there is no result for variable raised to variable. There is no result for variable raised to variable. So what you will do, you will take log on both sides. So you get here log of y equals to log of x raised to tan inverse x. Very next step, what will happen? this will be log y as it is, and here you will have tan inverse of x into log of x, and see this is u into v. The moment you take log, variable raised to variable becomes product of two functions, independent functions. This is u, this is v. See here, what was in the power as a variable tan inverse x, it has become the coefficient here. Okay, so this is homework. Same way you will try solving eighth problem. See, what is eighth? Eighth one is sine of x raised to x. Okay, see, try to understand. In seventh and eighth, in seventh you have x, the power of sine x. In seventh, what you see is this x, is power of sine x, but here this x is not power of sine x, it is power of x. So what you will do, students? Okay, let me give you some hint. Here I will write y equals to, let y equals to sine of x raised to x. Okay, now since here what I will do is, initially I may not take log. Taking log initially is not required, because here you have it sine of x raised to x. Please understand, this is not sine x the whole raised to x, it is sine of x raised to x. So as I will differentiate it, differentiate with respect to x, I will get here d by dx of y equals to d by dx of sine of x raised to x. I know you all are thinking that why are we not taking log here? See, we are not taking log here because when I look at this function, I understand it is a sine function. It is a sine function, and the angle of sine function is variable raised to variable. So that variable raised to variable is coming later. Okay, so the next step, see what will happen, students. If I ask you what kind of function is this, what function is this, if I ask you, your answer will be it is sine function. It is sine function, and it is not sine of x, it is sine of f of x. So you will have cos f of x. What will be the answer, students, for this? The answer will be here d by dx of sine x raised to x is cos x raised to x into cos x raised to x into d by dx of x raised to x. Okay, then write this as 1. Why write 1, students? Because here you got d by dx of x raised to x, and for x raised to x there is no ready-made result. It is not x raised to n, it is not a raised to x, it is not constant raised to variable, it is not variable raised to constant, it is d by dx of x raised to x. So what you will do, you write this as 1, and then you start writing let u equals to, I am now taking u, a new variable I am taking, u, let u equals to x raised to x, and here you will take log, you will get derivative of u, that is you will find du by dx. This du by dx is actually d by dx of x raised to x, which you will substitute in 1, and that will be your final answer. So these two problems are for you to solve, number 6 and number 8. You can replay the video and learn it. Thank you.